in what we did today. And although we do now have to factor on our own to find our roots, one thing that will be easier about today is that right from the get-go, you already know what the leading term is. You have to think about that a little harder when it's in factored form, like we just did on our last homework question. But right now, I already know that this is a positive odd. So it's going to be linear-like, but have a positive slope. So it's going to start low and high. Where the extra work comes in is having to just factor on my own. And factoring, even though we're past that chapter, factoring is something we will be doing all year long. So the first step in any factoring problem is to pull out a GCF. Oh, Owen, is there a GCF here? 2 and then what? 2x. And then what am I left with, Owen? Very good. And then once you pull that GCF, you look at what's remaining. It's 3 terms long. So you would guess and check or split the middle term. That part kind of depends on your preference. You should notice that this has a special pattern. What's the special pattern? That's a perfect square with the square root of x. That's a perfect square with the square root of 3, right? And 3 times x doubled gives you 6. So this is a perfect square trinomial. Remember when we completed the square, by the way? And we took half of b, so half of negative 6 is negative 3. And then we squared that, and we decided to add 9 to both sides. So it's a perfect square trinomial. It already has that feature going on. So when we factor this, it factors into x minus 3 times x minus 3, which is otherwise written as x minus 3 squared. And then from here, it's just like it was last night. So Jack, what are my roots? Birmingham. I need numbers. Where is this? What are my x-intercepts going to be? When is this thing going to equal 0? Positive 3 I agree with, because 3 minus 3 is 0, and 0 times anything will 0 it all out. I don't necessarily agree with 2, though. If I plugged in an x of 2, I'm going to get 2 times 2, which is 4, times negative 1 squared. That's not going to give me 0. How do you think about, how did you get 3? Right, so you just teed that up. I don't know if you realize mentally that that's what you did, but you teed it up. So what's the other factor that you have to tee up? (2x). So if 2x equals 0, Jack, what does x equal? 0. So your roots are at 0. And is that a single, double, or a triple root? What do you think? Sierra. Is the 0 root a single, double, or triple? Single. So it's just going to cut straight through that. I don't know if it's going to go up or down yet because I haven't thought about my end behavior yet. And my root at 3, single, double, or triple, Faye? No. This came from a double. So it's going to do what there? Is it going to cut through, bounce, or squiggle? Bounce. You don't have to write those, but I think it's going to be helpful for some of you to make sure you don't let that fall by the wayside. Okay, so then we're going to start low. We're going to cut straight through our first root. And then at some point we have to turn around and we have to bounce off our second root. And then again, the ending high takes care of itself, or should. If it doesn't, then that means maybe you bounced when you shouldn't have bounced. Or maybe you cut through when you should have bounced. Any questions on that? Okay. On B, what is the degree, Alexa? No. See, now you're adding them all up, aren't you? See, if it's in factored form, 2 and 1, you add them up. If it's already in polynomial form, it's just whatever this first term is. 4. Does that difference make sense to everybody? If it's in factored form, you have to add them all up. If it's in polynomial form, you just take the first number. So, and that's a positive even. So, does it open up or down, Alexa? Good. Now, we have to factor. Is there a GCF, Bella? Okay, so what's your method? Okay, so I'm looking for two numbers that multiply to get, add to get -5. Do you know what they are? Very good. So, splits the middle term. The middle term is an x squared term, so when I use those -1 and -4, I do minus 1x squared minus 4x squared. And then I group, take out an x squared, left with x squared minus 1. Take out a -4, left with x squared minus 1. So my splitting the middle term grouping gets me to there. Then what, Eric? I could. I'm not really done factoring, though. How about both of them are perfect squares, right? So what does this factor into? And then this one? Good. All right. So back to the point I was making when I first talked to Alexa about the degree. Do you see how it's in factored form? You have a linear factor with a degree of 1, a second linear factor with a degree of 1. This is where you add up 1, 1, 1, and 1, so it has a degree of 4. And that came from the fact that once I were to multiply this all out, that leading term would have been x to the 4. So where are my roots, Morgan? Good. And so if I'm opening up, that means I'm starting high, ending high. So, and they're all straight cuts because they're all with a degree of 1. So I cut down, I cut up, I cut down, I cut up, and it naturally opens up. When it's already a polynomial, I can see it's 1x to the 4th. So that's a positive 1. So I knew it was positive. Versus like yesterday when I needed to know the leading coefficient, it was started in factored form. That part's a little bit harder. So I don't have to factor here, but I have to think a little bit harder about what the leading coefficient will be. When I take -2x and square it, that'll be 4x squared. When I take x and square it, that'll be x squared. So that was a 4x to the 4th would have been my leading term. So I knew that was a positive even. It takes a little bit more effort, a lot more effort to come up with that when it's in factored form, but the less effort in the fact that it's already factored. Versus here, we have to put in our work factoring, but our leading term is right there from the get-go. And our last one, we have a GCF cake. X cubed, what does that leave me with? And how do you factor this, Kate? Like what method do you use? You do? Man, how many people split the middle term on something like that? Oh, how many people guess and check? Let me tell you how easy it is to see your hands raised when you don't unbend your elbows. Yeah. Well, when the leading coefficient is 1, the two numbers are your two numbers. Like over here, she said her two numbers were -1 and -4, and it became -1 and -4. This one I can kind of see why people would split the middle more so because that x to the 4th might throw you off. But guessing and checking, I want eventually to be just as easy. So that has to be x and x to make x squared. And then we have to make -12, which there are several ways to do that, but your outer and your inner have to make -1, which would be -4 and +3, and your x cubed out in front. Okay? So, where are our roots, Natalie? -3, correct. 4, correct. 0. Now, Natalie, I forgot to ask you a very important question. -3, is that a single, double, or triple? Single, so it's just going to cut straight through. 0, is that a single, double, or triple? Triple, because it's x cubed. Are we all with her there? Good job. So that's a squiggle. And the 4 was a single. So it's going to cut straight through. And the overall degree, Jason, is what? So is that even or odd? Odd. And positive or negative? Positive, odd. So that means it starts how, ends how, Jason. If it starts high and ends high, then it's got an even pattern. Start low and high, does that have a positive slope overall? Yes, so that would be the one. So we're going to start low prior to hitting our -3. We're going to cut straight through that. Then you're going to squiggle through 0. So remember, when you squiggle, you draw it like it looks like you're going to turn around, and then you renege, and then you actually don't. And then we have to turn around and hit 4 straight through on our way back up. And then Jason's got it. The start low and high took care of itself. Yes. I have more important things to worry about that I'm teaching you. So I will be honest, I tend to look past it, but when someone grades your regions, they won't. So you want, if it ever says anything to graph, make sure you graph your line. All right, how are we feeling? Is this okay? Is it clicking a little more today, hopefully? Any questions? Okay. Now, this one's going to be quite a bit different. So here's the function right up top. The reason it's different is because it is not factorable by your traditional method, right? Grouping is not going to work. I'm just going to tell you in advance, okay? Splitting the middle term, all that other stuff is clearly not going to work because there's 5 terms. So just because those methods don't work doesn't mean something is not factorable. Sometimes it does, but sometimes things are still factorable regardless of that. So the way we're going to factor is we're going to actually cheat. We're going to look at the graph, look at our roots, and go backwards and turn our roots into factors. For example, on this one, if I see a root of -3, I'm going to write a factor of x plus 3. If I see a root of 4, I'm going to write a factor of x minus 4. If I see a root at 0 and the graph is squiggling through that, I'm going to write a factor of x to the 3rd power. If I see something that bounces, like where was this one at 3, I'm going to take a factor at, or a root at 3, turn it back into a factor at x minus 3, and since it bounced, I'm going to square it. Do you think we can do that backwards? We just have to cheat and use the calculator to see where. So, everyone type that into your y equals. This Corey, what an MVP. Although maybe not. Because if you typed it in, it means you weren't listening to something very important I had to say. Oh, you did. He's a multitasker. So we type that into y equals. And this was nice enough to already fill in an appropriate window. It, interestingly enough, went to 500. I have to be honest. I would look at this. What's the y-intercept going to be? 70. I would probably have gone like negative 100 to 100 to start, but maybe clearly that's not enough. So make your window what they have your window to be, negative 10 to 10 on the x-axis, negative 500 to 500 on the y-axis, and then graph. Now these roots are pretty perfect. You can count them and see that you have a root at negative 1, 2, 3, 4, 5, 6, 7. Everyone see that? So we'll put a root at negative 7. There's a root at negative 2. There's a root at 1. And I'm just pulling this off Corey's calculator. And it looks something like this. It goes pretty far down, and then not so far up, and then not as far down. But a couple things to note. Oh yeah, that makes sense. It's a positive even. Look at your equation, and you realize, oh yeah, it's opening up. That's great. You also do know your y-intercept is 70, so why not just label that 70? But the point is going backwards from your graph to your factored form. So Angie, I'm going to start with you. And I'm going to start you at the root of negative 7. If negative 7 is the root, what's the factor that would have come from? Perfect. And Lucas B, if negative 2 is the root, what's the factor? Good. Chris Brooks, what's the next factor that goes along with the root of 1? Good. And what's the factor that would go with 5? Georgia. X minus 5. Perfect. So there it is in factored form. Here's one thing worth noting. There are a gazillion graphs that would have that same shape and would have those same 4 roots, but might not be that equation, right? What if I did this? Don't do this, just watch. This is just listening. What if I did this? Still came down through negative 7, still went up through negative 2, still came down through 1, and still went up through 5. Would that graph that I just sketched and the original graph have the same equation? No. What would be different, Lucas? If you call this graph number 1 and this graph number 2. You're right, they wouldn't be the same. The slope, that's one way of thinking of it, but what did if you go back, think transformations, think reflections, shifts. The y-intercept got, yeah, that's one of many things that's different. But what transformation would get you from graph number 1 to graph number 2? Vertical or horizontal, that kind of thing. A what? Vertical stretch, right? So there is some coefficient A that we have to think about that could be out in front. Now, what is your leading coefficient of this quadratic, or this polynomial? 1. So in this particular case, we already know that a is 1. But if I made a 6, this could be the new graph that would still have those same 4 factors, but would just have a different leading coefficient out in front because it vertically got stretched. Or it could be vertically compressed. So from 1, I'll do graph number 3. I'll still cut through -7, cut through -2, cut through 1, and cut through 5. Still opens up, right? But it's not as tall. The slope isn't as steep as to what Lucas said. So rather than having a coefficient of 1, what might the coefficient be in a case like that? 1/2, 1/4, right? Something less than 1 that would vertically compress it. So we don't have to worry about a right now because we can see that it's 1. But we're going to actually be writing the functions tomorrow. We're going to be given the graph, and we're going to have to write the function, and we're going to have to put more thought into what a is because we won't have this original version to look at. Here we have the original version. We know the leading coefficient is 1, so we don't have to worry about anything. Okie doke? Now I have another question for you, because we're done with this one, but I think this is worth knowing. How did you know that 5 turned into a factor of x minus 5? Yeah. Meaning what?
You just subtract 5 and get x minus 5 equals 0.
Now, I have a better question for you because I'm impressed. Is that actually what you thought of, or did you just kind of know it because it was the opposite
I
sign?
just kind of assumed that's how you did it.
Right. So I think most of you who are going from roots right now to factors are just flipping the sign, right? Seems pretty simple. You kind of came up with that pattern on your own. But technically what you are doing is you're saying, okay, my root is x equals 5. Let me do the reverse of teeing it up and go backwards and get this equal to 0. So now there's your factor, which you don't necessarily have to do with whole numbers. But I will tell you, if you have a root at 1/2, if I show you a picture of something that's got a root at 1/2, you can't just write x minus 1/2 as your factor. That's not allowed. You actually have to go backwards. So the first thing I would get rid of is the divided by 2. I would multiply both sides by 2, and I'd have 2x equals 1. And then I would subtract the 1 over, and my factor that would go along with the root of 1/2 is a factor of 2x minus 1. Can you see it? You can do better seeing it forwards. You can see, oh, I'd add 1 to both sides, and I would divide by 2. But you are reversing that process, and we'll have to do that because not all of our roots will be whole numbers. They will be fractions. And you'll have to turn a fractional root back into a linear factor. Do you follow? Okay, last question. Ooh, the largest root. Is this groupable? If I take out an x squared, I'll be left with x minus 9. No matter what I take out here, I'm not going to be left with an x minus 9. So it's not groupable. So I need to find the largest root, and if you can't factor by hand to find the roots, you have to do it on your calculator. So, type this in. What's my y-intercept? 22, so I don't think there's a need to go from negative 500 to 500. Negative 50 to 50 should cut it. Now, am I seeing all the graph? This is a very interesting point, because there was a Regents question that came up, and if I can find it, I will. There was a Regents question that came up And if you were just looking at the negative 10 to 10 window, you were kind of missing some of the graph. But you almost didn't realize it just based on the way it fell. But you should, in hindsight, you should have realized it because the end behavior wasn't appropriate. This one, being that it's positive odd, starting low and ending high is what you should expect. So we can feel pretty confident that this isn't going to turn around again. Do you follow? And then to answer their question, between what two integers does the largest root fall? Well, here's my largest root. 1, 2, 3, 4, 5, 6, 7. It's between 6 and 7. Okay? Here's the other last skill that you should already know, but I'm going to use this as an opportunity to reteach you. What is the exact value of the largest root, or how do I find it? I know it's between 6 and 7. How do I find it exactly? Bella? Very good. 0. Second trace is my favorite menu. I want to find zeros. I want to bring my cursor to the left of that 0. So I'm going to scroll over. And just to the left is good. Enter. Then I'm going to need the right bound. So I'm going to bring my cursor to the right of that, which is just above. Enter. Enter. 6.7320508 to be exact, which is between 6 and 7. Okie doke. Any questions? Okay. Couple things. You have your homework for tonight because you're doing this from last night. If you didn't get this, the last night's done, the revised version, you can grab it online and print it out. It's on my website. Also, I'm having my friend Corey pass back your tests that you already did corrections on in class. Still, some people have some things wrong on there. So take those back, and I'll recollect those with your final corrections on, say, Wednesday. I'll collect on Friday. And don't move an inch because I'm going to find that review question for you.